Thomas Chirulika here, Sales and Service Engineer for Saro Agro Industrial Limited. Our task today with my colleagues is to try and explain, describe and make people understand the PLB plant so that when clients want to come and buy, they should know what they are buying. And even our colleagues that haven't got knowledge and information about this, they should be able to be explaining, at least explain to clients what our implement is, what it can do. So we'll start with description, then thereafter we will go into parts identification and actually talk about these individual parts. What do they do? What is their function on the planter? And then later on we talk about seed calibration. It is important to calibrate your seed nicely and properly for you to get the intended yield. You don't just plant, you need to know how much you need to plant per hectare. Once you've known that, then you push it into the planter, you instruct the planter. This planter is going to do that for you. Through using the manual, we're going to explain in details on how to adjust, how to do the feeding, and also how to do the calibration. And after that, we close up with just a few hints on what other products that are not listed on this planter, which as Saro we have tried, and the planter has been planting nicely. To start with the introduction, this is a PLB model planter coming from Brazil. Specifically, this is the Baudan company that is based in Brazil that manufactured this. Then we as Saro, we are the people that supply these things. So we've got business franchise with them. We buy a number of things. Apart from this, we also buy disc harrows, we buy subsoilers and many other things. But today we're talking about the planter. So this planter was designed to plant a number of seeds, which I'm going to list. But then I must mention that this is not a pneumatic planter. It is a metering planter that uses discs to drop the seeds. The discs that are put in there, they have got holes, and then there's a knocking mechanism that will drop the seeds depending on what you want. And then it comes with different sizes and different holes that will accommodate a variety of seeds that you might as well plant. Okay, so it is trailed by wheels. You mount it onto the tractor and then you start pulling it. The moment you pull it forward, there are wheels that are going to be rotating, and in the process it will start registering the seeds according to your adjustment. So there are different parts that will be involved there, but it is that you plant maize, you plant soybeans, you plant you can plant rice, plant groundnuts, plant cotton, plant sunflower. We have also tried to plant castor bean. So it also comes with a blind seed plate. This means if you are trying to plant something that is not listed on the list that is given to us by the manufacturers, they have given us a blank or blind seed plate, which you can perforate, make holes on it, so that you are able to plant whatever you want. You can use a number of drills, drill bits. You can make 13mm holes, 15, 16, depending on what you want, and then you can also just calculate the number of holes that you want on the same. So therefore this planter is very versatile. It's going to plant for you a number of things, and actually it's a precision planter. It drops seeds according to what you've instructed it on the same. So having talked about that, we will now get closer to try and describe it more by looking at the parts that are going to be involved, that are on the planter, which will help you plant properly. It's important that you know all these parts so that in case you bought it, you'll be able to use the planter properly, because if a certain part doesn't do the job and you understand what it's supposed to do, you'll be able to fix it. You'll also be able to identify it, even for us as a way of feedback. Okay, so talking about parts identification and description, we will start with the main frame. This is about 4.8 meter frame, where all these other row units are going to be connected. And this is the one that will actually be connected onto the tractor, and to be able to lift all these other parts, a very important part. Without this, then you do not have a plant. So the function is to put together all these things, make up a planter, and this is the main frame. So these parts are all connected to the main frame using various brackets, and there are bolts that are also framing all these parts onto the frame. Okay, so that is its function. But then just below the frame here we have the wheel. This wheel you find it even on the other side. This is a stabilizer wheel. You can also use it for controlling your depth. So this is to avoid the planter you are planting, it's going like this. So the wheel will position the planter nicely. And many of us now have even ended up using this wheel to mark, to help us mark where the marker has stopped working. Or in the case of the two-row. The two-row, unfortunately, cannot be accommodated with the marker. Even if you put the marker, you cannot use the marker nicely. So we end up using these wheels to mark nicely for us. So that is the left wheel. Okay, so this is the row unit. When I talk about the row unit, I'm actually talking about the whole system, the whole unit being connected to the frame, going backward there. It does its own parts as well, but this is the row unit. The function of the row unit is to actually plant and apply fertilizer. Whatever is there, the intended purpose is to do the plant registering and also application of fertilizer. Then we talk about the other parts, talking about how they plant, how the fertilizer is going to be dropped, and then we talk about calibration, we'll go into those details, but that's the part. Then down here, we have the quarter disc. That is part of the fertilizer registering system. It actually opens up and cuts, opens up, and then fertilizer is going to be dropped. So you find that if you are talking about a 4-row, all these parts are there on each row unit. The frame is one, the wheels are two, but these, like the quarter disc, you find on each row unit, you have a quarter disc and you have all these brackets that will help you set up the planter nicely. So when you look at these are brackets that are adjustable. You can just undo. There are U-bolts behind there that will hold the clamps in position. Then you can now loosen them and move the planter depending on what row spacing you're trying to achieve. So you'll be able to move it up this side and also move it this side. And then we have got the marker. In the case of this planter, the 4-row, this marker, which is adjustable, there are formulas that we use to calculate to know where do you place your next wheel as you are planting. This is ideal because you need to measure up the lines. When you have the first pass, you come back, you don't need to have gaps between the passes. You need to ensure that if you're planting at 90, it should be 90 from one line to the last line. And this is why you have the marker, which is fitted with a disc. The function of the disc is to try and cut for you so that it's visible as you are coming back to know where you place your wheel, and then you'll be able to do that. So since it's adjustable, it accommodates a number of tractors. You find that your tractor is wider, another one is narrower, but then using the marker, you will be able to mark nicely without problems. Okay, so talking about hooking this onto the tractor, we've got the right lower arm, left lower arm, and then the top leg. This is where you put the pin. So the tractor is fitted with the 3-point linkage. So that 3-point linkage is going to connect up these parts, and then you'll be able to lift the tractor. You can do the levering adjustment by lengthening or shortening the top link. So this is the part that connects up the PLB to the tractor. So the tractor should have this feature, which is a 3-point linkage. And we also have this rod. What it is, when you are planting, it's a process. You need to have one driving and another person observing the planter behind. And that same person will be able to use this rope. So this rope is the one that will be dropping the markers on the sides. So the rope is going to be adjusted in a way that when you pull one side, if you pull the rope on the left side or right side, the other part is going to drop down by gravity. So that will be marking. So when you turn, you are turning now going back, you're going to plant going the other way, you pull the other side, the opposite side. This one will go up and then the other one will be marking. So this is why you have got this rope. And the rope will be controlled by someone who will be sitting next to the operator. The operator will be focusing and concentrating on making the lines very straight. And the second person will be looking at they do the marking. Instead of coming off the tractor, you move, you go and drop it, and then you go and lift the other side. You are just going to use these ropes to do the marking for you, or to drop the marking. Okay, so the raw unit. Now we'll talk about the parts that are on the raw unit and their individual usage and why they're there. So we'll start with this part. This wheel, the black wheel, which can actually, when you lift it like this, it's turning. So the function of this wheel is to turn. There's a chain, and here there's a chain. There are sprockets. We'll open these up, you will see them. There are sprockets that are connecting up the chains up to there. Then there's a shaft turning the seed hopper. There's another shaft turning the fertilizer hopper. So for these to turn, they need to be turned by this. So when this is moving like this, it's turning a chain of chains here, a train of chains. Then the shafts will be turning. So the seed plates will also be turning, hence dropping the seeds, and then the fertilizer is also going to be turning. And there's a worm there that pushes the seeds onto the outlet. That is going to be done by the drive wheel. So this same wheel again, it's actually the one that does the covering. So you find that the line is opened up and the seeds are dropped. You can see the shape, the way it's designed, which is going to go over the line, and it pushes the seed by firming the soils on top of the seeds, and then covering is properly done. Behind the wheels, there are two scrapers. They are to ensure that when you are planting and it's wet, the accumulation of soil on the wheel is going to be reduced, or the soil should be scraped off. Because if you have soils accumulating without the scrapers doing their job, you have problems with covering. So find that this wheel is not doing the covering nicely. Okay, so next we have the seed hopper. This is the main hopper that does the seed register or seed planting. So we put all kinds of seeds into the hopper. It's about 45 kgs. But probably because of the fields not being even, you're not going to fill it up to the tray. You maybe pack it up to maybe 8 or maybe 5. But then the capacity is about 45 kgs. So you put your seeds in here, depending on what you are planting. Then you close up. We'll get into details in the seed hopper. What parts are there, what comes with the seed hopper. We'll talk about that. Then here you put fertilizer. It's actually mainly we use this for D. I must mention that you do not apply top dressing using this planter. You have to use fertilizer spreaders or other things. Then this one will do your basal dressing, which is compound D. That will apply that. Okay, so then there's at the bottom here, there's the quarter disc. Like the first quarter disc we talked about, which is for fertilizer, we have also a quarter disc for seed. The main function for this is to open up. Once it opens up, then there's a wheel next to it which pushes the soils tries to put the soils on the opened up area, and the seeds have been planted. Then this wheel comes and it will cover up. Then we have this part which you can use for depth control as well. There are some dimples here. You put it down or up. That is so these are the parts that you are going to be familiar with when you have bought this planter. So every time you have problems, you should be able to specify to say, I need a wheel. My wheel has broken down. My fertilizer hopper is not working. My quarter discs are not working. And the other small parts that are inside the quarter disc, inside the seed hopper, and also inside the fertilizer hopper. But then, since we are here already, I can as well talk about the accessories that come with the seed hopper, and these are the seed plates. Okay, it comes with about 7 seed plates extra. There's 3 for maize, and then 2 for soybeans. There's also 1 for sorghum, and then there's also the blank one. This is the one that you need to perforate, make holes and accommodate whatever you can order to use this plant. Okay, so these are the things that come with the seed hopper. These will help you now plant nicely. You can see quite a number. This is why we say the planter is so versatile that you can choose amongst these to do whatever you want. There are other seed plates that you actually, this is just a package that comes with this. Other seed plates we stock in our stores. We've got seed plates for sunflower, those are even metallic. We've got seed plates for even beans. The other beans, not the soybeans, and also seed plates for rice, different sizes and different types. So all those will come with the planter to help you plant. Okay, so in the fertilizer hopper, we have these. These are sprockets. Each row unit comes with about 16 sprockets, starting from 8 up to 21. Some numbers are skipped. So these are now going to be very important when you start calculating. You are planting maize, you choose what combination to plant for you. You're planting soybeans, you choose what combination. Of course, there's a manual to help you and guide you to say if you want to plant seeds, let's say soybeans, you want to plant it at 40 seeds per meter, then it will tell you to say if you want to plant 40 seeds per meter, then you put this sprocket and this sprocket, then you get that. But then you don't need to get that as gospel truth. You try it. You go find the flat land, and then try driving and see, count if they are 40. If they are not 40, this is why we have a number of sprockets. You try another one, try the next one. But trust me, with my experience from the time I started working with this planter, it is very, very precise. If it says put 5, put 8, put 10, you do that, you try it, you will get just that. This is my experience with this. Okay, so we want to look at the parts that are in the hopper, seed hopper. And this is where most of the problems are found. Mostly people do not know and do not talk about the seed hopper being put nicely. There are parts which are going to go into details one after the other, show you how they are supposed to be fitted. If you fit them wrongly, then you are not going to plant. So we'll start with this Chinese hat on top. There's a bolt that you unscrew. You don't use any spanner, you use hands. Once you keep on unscrewing it until it comes out, then you move it out like this and put it somewhere. The first part we are going to talk about is this. This is what they call Chinese hat. Anyway, I don't know, it's actually seed distributing unit, but looking at the shape of the part, we have decided to call it Chinese hat as farm machinery department. But this has nothing to do with Baodan itself. Okay, so this part, the function of this part is to carry the weight of the seeds and protect the rotating part, especially the seed plate, which you will see down there. Imagine you have about 45 kgs of maize. They are now pressing on the seed plate, which is supposed to be rotated. So instead, this should soak up all that force and weight, and then the seeds should be sliding slowly into these spaces, and then they are being picked by the seed plate. So it does that, and also it accommodates the knocking mechanism. There's a knocker here. This is for soybeans. It's got 2 plates on the knocker. So this is for soybeans. So this knocker ensures that by force of inertia, some seeds may not go over the seed hole where the seed is supposed to be dropped. So it ensures that all the seeds that reaches the seed hole are supposed to be dropped down. So this is the function of the knocker. You can change this, put another one. If you are planting maize, you cannot use this. I think that's the other part I need to emphasize. When you are planting maize, know what to change. You don't put seed plates for soybeans in order to plant maize. That would be a problem. You won't plant nicely. You need to change the seed plates, put the proper seed plates for maize, and put the knocker for maize, and then you close it up, and you'll be able to plant. We'll talk about seed plate selection as well. Okay, so this is the Chinese hat. Now, when you look at this hat, the design, there's one feature that is very important. Looking at it, there's this lip. So there's only one place when placing it into the hopper where this lip will sit. So if you just put it anywhere, you can lock it up using the that bolt. Place it, and you think it's okay, but there will be spaces in here which will be left. Then the moment you try and turn this, you find that seeds will be coming out left, right, and center, because it hasn't closed up nicely. This rib is sitting on a wrong position. So this rib has a place. When you look at inside, there's a place there. When you go around this, there's only one place where you put the rib there. If you don't put it there, then even where the seeds will drop from here, where the knocker will sit, the knocker will sit somewhere else. So this is going to align the knocker and also make sure that the Chinese hat is sitting properly when you put it nicely. So you get it like this, and then you place it there. It actually sits. This thing can be put like this, and you don't care. You just start screwing it. You can tighten it. It will be hard. And the moment you start turning, you see all these other spaces there. There are some spaces, and then it's not even sitting nice because of that lip there. And then that's where the problem comes in, and you don't plant nicely. So to avoid all kinds of these things, if you see that your planter is spilling seeds from where it's not supposed to drop seeds from, check your Chinese hat. Is it properly positioned? And then if it's not, you position it nicely, you put it there. You lock it here, it will actually tell you that no, now I'm seated. You see it's there, and now you're going to see that the knocker is right on the outlet where the seeds are going to drop from. Now imagine this is somewhere else, and the knocker has got those plates that will actually protrude. It will be pressing against that. You damage the knocker and also damage the seed plate. So that is the part that we need to be careful when placing it in position. The next part is the seed plate itself. So this seed plate is like this. There is this flat part, very flat, nothing is there. Then there's this other part which has a ridge. There are actually some inscriptions there. This is where we even find the part number. You are going to see actually it's even written this side down. Other people tend not to read whatever is given to them. So if you put the seed like this, seed plate like this, it will sit. But then this ridge now will be in conflict with the Chinese hat. Then the wheel will not be rotating freely. Then what happens? You will be skipping. You won't be planting evenly. Some parts will be planting. This wheel depends on just the planter being trailed. It doesn't have a motor to force things to rotate. So you find that it will just be sliding and skidding without rotating. And if it's not rotating, you are not planting. So please, this seed plate, either you put one for maize. If you look at all the seed plates, if you look at all of them, they have got this same ridge. All of them. You look at this one, there's a ridge, and all that, all of them. So there's a flat surface side, and also the one with the ridge. So ensure that as you are pressing that seed plate in position, you need to put it like this. The one that is flat, the part that is flat should be facing up. Then don't worry where you can lock it up from. You can lock it up like this, or like that. It can sit. As long as it is facing down, no problems. You can see that seed will sit there and only be able to drop when they reach this part. This is the part where seeds will be dropping from, going down to be planted. Okay, so that is about the seed plate. The next third part, the most important and the most confusing, we have what we call the bifacial plate. This one. You've seen how it is positioned. Equally with this one, there's a side that is flat. Okay? Then there's a side that is ridged. There's a ridge on the other side. Now, when you look at this, initially these people, the Baudan people, used to also make seed plates that are 8 millimeter thick. Our seed plates are 4.5 millimeter thick. So 4.5 millimeter thick, they even actually indicated on the bifacial plate 4.5 this side, and then you have 8 millimeters. It's not very visible, but there's 8 millimeters this side. So on this bifacial plate, they call it bifacial because you can use it on both sides, provided you've got the correct seed plate. So if you are using seed plates that are thicker than 4.5 millimeter, you put this thing like this, because you have that space that is supposed to be covered, and the seed plate is bigger. Then this thinner seed plate, which is 4.5 millimeter thickness, you now put it where there is already a ridge which covers up for the other part which is thicker. So there's a ridge here which is about 4, and this one is 4. So 4 plus 4, somewhere it gives you about 8, and then it will seal nicely. If you put it like this with a thinner seed plate, there's going to be some dancing there at the bottom, and some grains now will go past this, they will go and all that. So this one also problems. Apart from that, you can see that there is this hole here. So this hole is the hole that allows seeds to go down, because seeds will be sitting here on top, and then they only drop through the hole. Now this hole has to be in line with the seed delivery tube. So when you check in the planter inside, the seed delivery tube will sit at the back of the hopper here, not in front, here. You can even see it's plastic, and it channels all the seeds up to the seed quarter unit down there. So when you are placing this one, in as much as you face it up the correct position, if you do not position the hole nicely, for example, this planter can lock even in this position. There are some lockers. There are these lockers. This locker and this one will lock this bifacial plate depending on where you put it. So you can even lock it like this. Sit like that, then you turn this. It's now locking. But where is the hole? The hole is not in line with the seed delivery tube. It's here. So this is where the grains will be dropping from. So you will see situations where grains are now coming out from a different angle instead of them being channeled by the seed delivery tube into the soil. So you have to put this right where the seed delivery tube is, like that, and then you lock it. It's now positioned. You can't turn this because it has been locked there, and the seeds will be dropping, and they will find the seed delivery tube, which you channel now the seeds onto the floor or where the opening has been done. So first thing, face it the correct face. Let it face up. The ridge should face up. Then the hole where the seeds will be dropping from should be in line with the seed delivery tube. And after that, you lock it. Once this is done, you get your seed plate. This one should face it down. The first one should face up. This one, the ridge, we are talking about the ridge. The ridge now should face down. With this one, at least it's written this side down. You put this thing like this. Then you lock it up. Okay? And then you get now the Chinese hat and put it. This has a lip, and you put it there. And now you can get your locker or your nut, your bolt I mean, which now, as you are locking it up, do not leave it loose. That will allow grains now to go through those spaces. You have to ensure that as you are turning it by hands, don't use spanners, and then this is not dancing. You are good to go. So that is the way these things are supposed to be positioned in the box. Without positioning them properly, this planter is useless.
Yes.
Okay, so talking about the fertilizer spreader as well, we thought it's wise we just explain a bit the inside of the fertilizer spread hopper. We've got 3 parts here which are supposed to be taken care of. The first one is this black block. This one, the main purpose of this is to ensure that whatever fertilizer you put in the hopper does not go direct onto the outlet, because the planter will be stationary and it will be applying fertilizer by gravity. So it ensures that fertilizer sits in here and only be pushed by this worm towards the outlet, depending on the speed and on what calibration you have done. So now this, as you can see here, it is sealed with silicone on the sides. This is to ensure that fertilizer does not drip down to the outlet. Okay, so you need to check your planters. Once you've bought a planter today, it will be intact, nothing like that can happen, no leakages. But the following season, you don't know what happened. Maybe there are some cracks, you need to seal it up, ensure that your fertilizer does not leak to get to the outlet down there. So right underneath this block, there's one hole which allows fertilizer to go down. You will see it when you look at it from the other side. The fertilizer tube is actually connected to the hole and takes the fertilizer down onto the quarter disc there. Okay, so that is supposed to be taken care of, and ensure that when you are planting, once you are done with your planting, you clean this hopper with warm water. Probably you can even use hot water, so that all residues of fertilizer can be pushed down, and then you have this thing not having been affected or not being affected by fertilizer. Then there's a worm, this one. So this worm, its main job is to just, when the shaft is turning, it's put in such a way that it channels or pushes fertilizer from here down to where the hole is. So the rate at which it pushes, that's how much application you're going to have per hectare. We'll talk about that when we start doing the calibration. So you need to ensure that this is put properly. Those that would want to repair this, want to open up this, the worm should face that way. This part should be on the left. Then there's one part that is, you can't see it now, it's facing the other side. Meaning that when you are turning the shaft, the fertilizer has to be pushed towards that instead of away. If you change this, you're not going to plant. Fertilizer will be pushed away from there and never go into the hole. So that is the other part. Then below the worm, there's a plastic. That plastic is there to cushion just the gap between this hopper, and it sits in between the shaft and the hopper itself. But this is a very delicate plastic. We recommend that you change it every season, and these are very cheap. We have them. It's even very easy to use it. But then also on the sides of this cover, you need to seal with silicone as well. If you don't find that fertilizer, it's going to go down there, and also this can force the cover to move away from the position. So if it sits, it turns a bit, then it disorients everything. Things won't be working nicely in there. And then there's a shaft. The shaft has to be cleaned every now and then. You clean it with hot water, especially once you are done with your planting. You can remove all the bolts, push out the shaft, and then use a sandpaper, clean it and all that. Once that is done, put it back in position. Then you are good to go for the next season. People use these planters and then they have seen their grains germinating, they forget about the planter. They forget that they'll need it next season again. So it's important that these operations are done after planting. You remove all these parts. This one you just seal it with silicone. These other parts you remove them and then clean them. Once you've done that, then put it back. Next season you want to start planting, it's just planting. Then on the outside there are some bearings there which you need to grease. That is very important, and many other parts that are supposed to be greased on the raw unit and on this hopper. Okay, so we are now coming to the last stage of our video, where we are talking about planter calibration. I must state that it's important to know the importance of calibration, and this is the process of trying to instruct the planter to plant according to the requirement of seeds per hectare, and also the output, the amount of fertilizer you need to apply in a hectare. So it entails or involves the proper adjustment, setting up the planter to plant according to the required seedlet or plant population per hectare. Having said that, I must mention that when you are planting, I'll give an example of maize. Let's say we are planting maize. there's a requirement for maize. For you to do proper maize, to get proper yield, we are required that, or we are advised that you plant about 36,000 to 60,000 range of maize per hectare. This will depend on a lot of factors. Your soil type. If your soils are very rich, you can actually put a lot of, you can go up to 60,000. Then there are those that would want to achieve bigger crops, and they are doing seed maize. They can reduce maybe up to 36 and then feed it, depending on what you want, all those factors. So in your case as a client, you need to change, see what you select. Say, okay, let's say we want to plant 55,000 seeds in a hectare. This is where calibration comes in. It starts from that. So we have a 55,000. Then how do we instruct this planter to do that for us? Then you are going to plant about 200 kgs of, apply about 200 kgs of fertilizer. How do you now instruct this? This is the stage we are getting into. So to start with, we will talk about what is required. What are we going to start looking at first? We said this is the driveway, this one, which does initiate all the movement. If it is fertilizer, it's this one to apply. If it is seed, it's this one to drop the seed. So what do we do? Next to this, this wheel, which is a compression wheel, and that also is also a drive wheel, there's a sprocket which is connected to the same shaft that is connected to the wheel. So this sprocket, we'll call it A for the sake of our understanding and our education. We'll refer this to the manual because the manual has these letters. So we have the first sprocket put here in line with this drive wheel. Then we have the next sprocket which is connected to the shaft that is driving the seeds, dropping the seeds. This shaft here, being turned by this, when you rotate it, it's the one that rotates there's a crown and a pinion gear there that rotates the seed plate inside. So when the seed plate is turning, there's a certain hole that allows seeds to drop with the use of the knocker. So the sprocket you put here, which is A, and the sprocket you put there, which is B, will give you the adjustment that you need according to what you want. So we are talking about A and B, and this side is only for seed. You want to plant seed, 55,000. There are also factors you need to look at. One, your spacing between the lines, that is intra-spacing, and intra-row spacing, which is spacing between the seeds. So that combination of these two will give you the population that you want. We'll get into details. We'll actually get into some calculations here to try and achieve and know what spacing do we need. I must mention that this planter can reduce the spacing to about 42 centimeters, small. That is about inter-spacing, which you can use for soybeans and other small seeds. But for maize, you can go up to 1 meter. So there is 100 millimeters, 100 centimeters, which is 1 meter. You come to 95, 80, 75, up to somewhere 42. So you choose amongst these calibrations or settings to select what is ideal for you. And then also from plant to plant, you can instruct this planter to plant at 20 centimeters, to plant at 18 centimeters apart. Then also set it that you plant at 70. So let's say you plant 70 by 20. Then you know in a hectare how many plants you're going to plant. We'll get into those calculations. But before we do that, we need to understand that we are going to change here the set that we put here, which is for seed. And the other side, there is a set for fertilizer. These sets are what are going to be helping us to plant according to the plant requirement. Other people, clients will come in with what they want to do. They will tell you, I want to plant my maize at 30 centimeters apart, and I want to space them at 90. We will actually go according to the customer requirement. We will not argue with them. But those that do not know how to plant, we can still help them with what we know. Like I've already said, you need to achieve about 55,000 on average of maize plants per hectare. So if someone doesn't know, says, I want to plant, you guys educate me, we'll do that. Those that already have information, they have gone to livestock and going to be educated on how they want to plant it. They will come with specific information. They will tell us, I want to plant my soybeans, maybe 15 seeds per meter. We will do that and we will instruct this with the use of the manual and their tables, which we'll get to when we start talking about that in details.
Okay, so we're talking about now get to the real manual, the actual manual, to see how we're going to do the calibration. We've identified the parts, the A, B, and C. So we are going to get to do 2 calibration methods. The one that we're going to start with is where the customer has got information and we just want to adjust the plant according to the information given to us by the client. Okay, so the first one, we'll ask the client for these important information. One, we'll ask for seed rate, or seed dropping, spacing per meter or from one plant to the next. So the client will tell us, I want to plant my seeds at 25 centimeters apart. This information will come from the client. Then we don't have to argue about it. That's how they want to plant it. Our job is to ensure that the planter is set according to what they want. That is first information. Second information, we will have to find out the row spacing, which is from one line to the next. So we are talking about this spacing between lines. Here we are talking about the spacing between seeds. So this is 25 centimeters and this is, let's say they say 80 centimeters. This we find it from the client. They did their research. This is how they want to plant. Whether they'll plant less per hectare or more per hectare, this is what they want. And ours is to ensure that whatever they want, they do it that way. So the first step that we do now is to ensure that this 25 centimeters, because now we will get to the manual itself, then we are going to flip the manual from the first page, just to show you how to go about it. This is the manual that you receive from Baudan, which comes with a planter. Then you start flipping the pages from page 1. You go until you find tables for different seeds. Okay, they are here. So first thing, you see the first table, seed distributing disc for each culture. Here, this is the first table you need to read. You've got soybean seed plates, maize and rice seed plates, then there's sorghum, and then there's the blind one. I think these are the number of holes that you're going to see. 90 by 7, this is all those, the thicknesses. Okay, and then all you do is the first plant that you find here is soybeans. But in this case, we are planting maize. Okay, so we'll skip this table and we'll explain more about this table when we come to soybeans. Okay, so we will have to look for a table that contains corn or maize. So this one is corn, this is beans, this is rice, and this is peanut. Then we also have sunflower and cotton. These are other plants that you can plant, but in this case our concentration is on corn distribution table. So now when you look at this table, we've got 3 columns. There is one motor A and the moved B. I think when I was explaining about the calibration, I started talking about the letters that we attach to the planter. So A, this is the sprocket that is connected direct to the wheel. And B is we are talking about seed selection here. So the B is the sprocket that is driving the seed plate. So we have the one that is connected to the wheel, and then this is driving a seed plate. So these two will give you, if you read here, there is quantity of seeds per linear meter. So there is 3 up to 6, rather 8. Okay, so the next thing we do is, okay, the client gave us that information. We have 25 centimeters. And this is quantity of seeds per linear meter. We all know that 1 meter is equal to 100 centimeters. Okay, so now we say, okay, the clients want to plant 25 centimeters apart. So now we divide 25 into, and we find our answer to be 4 seeds. So this 4 is the one we look for here. We come to this table and look for 4, because once we have 4 seeds in a meter, they are automatically going to be spaced at 25 centimeters apart. Okay, so here we are, the 4 is here. So whilst we are on this 4, you know going to go along this row and find the suitable combination that will be able to plant for you 4 seeds in a meter. And according to this table here, we are getting to 8 and 13. So 8 on A, 13 on B. 8 on a sprocket that is connected to the wheel, and B on the sprocket that is connected to the 13 on the sprocket that is connected to the seed plate, just underneath the hopper. So your job now is to just get 8 and get 13, then put them on the chain that is on the seed plate side or seed selection side. So how do you know what 8 is? What is 8 and what is 13? So this is where we get to check if you saw those the sprockets that we supply per row unit. We give you about 16 sprockets. You choose from that. So now when you get this set of sprockets, your job is to just count a number of teeth on these. So you hold one and start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has got 9 teeth. You come to the next one, you hold you get 1 teeth, you hold it, and then start counting from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now these are the numbers. So your job is to look for 8. You count how many teeth, you get the one that has 8, and then you come and get the one that has 13. So from there, you come and once that is done, you have the 2 sprockets. Then you do what? You bring them. So you have these sprockets selected. Your complete chain has to be A, B, C, D. So A we have 8, B we have 13. So this is seed and this is the fertilizer, like that. Okay, so this combination will plant you the correct seed rate per hectare, and once you put that, you put your seeds, you put that combination, then try look for a very dry ground. You don't drop the planter so much, and then just move it for maybe 10 meters, and then check how the seeds are going to be dropping. Probably you are just going to get the correct seed rate once you try that. So if it happens that you are dropping more than what is given, and in this case we have 813, so 813 is dropping more for you, which is never really the case, but this is just in case that happens. 8 and 13 gives you 5. So all you do, you're going to get 8 and put 14 there or 15. When you get a higher number, you are slowing the speed. A bigger pulley driving a smaller pulley, you are increasing the speed. A smaller pulley or sprocket driving a very big pulley or sprocket, you're going to reduce the speed. So it's about the rotation of the shaft. So once the shaft is reducing, and then you are actually increasing the gaps from one seed to the next. So this is how it works, and this is the process. It's very easy when the client tells you how they want to plant. Okay, so from here, we are sorted with A and B. Now we are remaining with C and D. This is for fertilizer. So the same client now has to give us important information. We next now go to 3, which is application rate. This is application rate. In this case, the client says 200 kgs per hectare. Okay, so once we have this done, 200 kgs per hectare, client tells us, this is what I want to plant. We are calibrating. We have done the seed. Now we're getting into fertilizer. Okay, so the next thing we do is we go to the manual again. Then now we start flipping the pages. We are going to find another set of tables. These tables are going to be very different from the seed tables. So we keep flipping like that until we find strange tables. In this case, the first table we have is this. And if you see, we've got a number of tables. So how do we know which table we are to use? So that is the first step, table selection. You know the application rate, and that application rate is in every table, but you need to choose the correct application rate. So we come to this one. The first thing you need to do is you need to understand that for this shaft that is driving the fertilizer, it actually borrows this drive from the shaft that is driving the seed. So there is that relationship between the two shafts. So you cannot go and look for fertilizer rate without putting into consideration the combination that you have found at first. So the tables that we need to find should have the first combination, which is 813. In this case, the AB, which is on the first table, is 817. This is not our table. We look at the next table, and luckily we have 813 here. And this table goes only up to somewhere there. Mind you, this is 812. So you cannot choose any other table because now the drive will be different. Okay, so we have here, we have another table that is showing 811, 810, 99 and all that. But in this case, our A and B should actually determine C and D. So we start from 813, which we found. So first table has been identified. So this table, the next step now is we ensure that we check what did the client say they want to what is the spacing between the lines. This column on top here, this row on top here, it has numbers from 42 up to 100. These are in millimeters. In other words, these are actually spacing between lines. Okay, so spacing between the lines, we have 42 up to 1000 millimeters. So we can actually take them into. So changing this 80 into millimeters, we multiply by 10. So in this case, we have identified the table. Next is to know which column are we going to concentrate on to find our 200, because on each column we're going to find 200, but which 200 is the correct one? So we come to 80, which is 800 in this case, looking at the table parameters. So this 800, we are doing elimination method. So now we are not going to look at any other table region but this one. So the column is here. These other columns are all useless. We are looking at 800 and we actually demarcate there. Then we also get it from there. This is where the line where we are ending our 813 combination up to somewhere there. Then we mark there and there. So now we are coming down, narrowing down everything. We are coming down to this region. So it's this region actually where we need to find our calibration, our 200 kgs. So mind you, 800 customer told us. 813 we found it because of what the customer told us. The customer told us he wants to space the seed at 25 centimeters. So now we are coming down to this. These other figures outside this box are useless. So when we reach here, we need to look for a number. According to the client, he wants to plant about 200 kgs per hectare. So we need to look for a number that is very close to 200 or exactly 200 if we can find it. So if we can't find exactly 200, we need to get the nearest number. So we start from the top there. We have 67 coming down. So we can find 177, we put it on bench, or we just, look at other numbers. This is too much until we get to 221, and then there's 199. So amongst these numbers, the one that is very close is 199. So the closest to 200 is 199. So we found 199 along this row. So now your job, like we did with maize, you start going, you start sliding, you start going until you get to find this number and also this number. So check this is D, check this is C. So what is it? There is 9,8. So now our formula is completed. 9,8 combination. So we have this, we have this, we have this, we have this. So 9,8, again the same process. You go to the sprockets and count. You find 9, you put. Count, you find the 8, you put. But be careful, do not swap these. Where there is C, put C. Where it says D, put D. That is the process. So in this case, we have calibrated. All you do now is to put the sprockets the way this combination says, and then try it. And once that is done, you are going to apply 200 kgs per hectare and also plant the seed rate that has been given to us by the client.
So with our calculations, we came up with numbers A, B, C, and D. So on A we found 8. Then on B there's 13 there. Then on C 9. And on D there's 8. So now what, like I said, these are the sprockets you put. So in case this is not the correct sprocket, there's a pin which you use your hands to remove. Then from there, you just pull it out. There's a locker there. Then you just pull this thing out. You can use your both 2 hands. You remove this and push in another one. If it's 13, push in another one and put it. Once you put it like this, then you just slide it in like that. And then you put your locker in. Though this one might have to get it a bit until you get to the correct locker. And then you close it up like that. Okay. When you do the same here, there, and the other side. That chain will do the fertilization. This one will do the seeding. Okay. You've seen this part here. We call it a tensioner. When you have put a bigger sprocket, you find that this chain will be very tight. So on the tensioner, there are a number of holes here which will help you reduce that tension. Or if you use a small, you put 8/8, for example, if you are doing soybeans, find that this becomes slack, very loose. You can move the spring so that the tension. So this is actually basically for just tensioning. You can see it shouldn't be very tight and it shouldn't be very loose. If it's too loose, it's going to be coming out. The chain will be coming out. If it is very tight, again, you find that it's going to have load on this, and sometimes it will be skipping and also just sliding like that. So you need to have that average tension, which is good for the turning of this wheel without problems. Okay, so you can do the tensioner, and then there are these bolts that are put to hold the cover. Covers are important to ensure that dust doesn't get to the chains. Of course, these chains you put grease so that they are turning nicely. But then these bolts, when you are changing certain number of combinations, will actually push you to an extent where this chain is rubbing against the bolt. So this is why there are 2 holes there. If it's rubbing against the bolt on top, you remove this bolt and put it at the bottom there. And then you do the same maybe in that one and also that side. So once that is done, you close it up again. And then put the covers. Those covers, you just remove them so that you're able to demonstrate. You put the covers on and then you're able to check. So as you are planting, your eyes should be on the shaft. Is the shaft turning? When the shaft is turning, you are sure that everything else is turning. Planting is very also being done. It is very important to be checking your planter every time you reach the end of the field. You can be planting 10 hectares, meanwhile nothing is dropping. So this is why it's very important. Also, as you are planting, come through and check the level of your grains. You check, okay, is this moving? Not. If there are 4 of them, are they moving at the same rate? If there's a problem, you check and then see where the problem is. And this is why we're trying to emphasize that you understand these parts. Okay.
Okay, so we come to the part where a client does not know how to plant. They just want to be helped to plant. Okay, so we have a system that we use to try and help the client how to do the calibration. So we start with we are saying it's advisable and important that someone knows the plant rate per hectare. This is maize. So we are getting the minimum, maximum. So 36,000 minimum, 60,000 maximum, meaning that you can do an average of 55,000. Okay, depending on the fertility of the soils and also what you want to do. If your soil, the plants you are doing is maybe for seed or for animals, that is up to you. So this is what we tell the clients. Say, okay, we'll try and get into teaching you what we can do. So in this case, when you look at those seeds that are being sold by these seed companies, they actually write to say the germination percentage is about 90, 98 and all that. There's about 2-3% maybe failing to germinate. So maybe 1%, others will say maybe 92, depending on your plant. So let's say you have 95 to 98 germination percentage. Okay, so meaning that we have about at least 5% that we need to add to this as an allowance. In case that seed won't germinate all of it. So you need to know what percentage is allowable. So we advise that on average you do 5%, at least more than what you want to see germinating per hectare. So this is where we start from. First, we're going to say, okay, let's start at 80% spacing. This is us advising the client. Okay, so if we start at 80% spacing, how many lines are we going to have in a hectare? Okay, because this is important. We want to know how many seeds what each line is going to plant. So now to find the number of lines, this is 80 centimeters. We say 100 divided by 0.8. Mind you, this is meters. Why 100? We are talking about a hectare, which is 100 by 100. So we are looking at how many lines are going to be planted along this 100 from here to there. And these lines are spaced at 80. So we say 0.8 into 100. We use our calculator here and we say 100 divided by 0.8. We will have 125 lines in 1 hectare. If we space our planter at 80, we're going to do 2 so that we're able to choose from that. So if we use 70 spacing, we divide also 100 divided by 0.7. We get to about 142 lines. So take note, these are the number of lines. We are trying to find the proper spacing between lines and between plants that will give this man the total number of plants that we need to plant. Okay, so in this case, our average is 55, but we want to plant seed that is not 100% perfect. So let's get it to maybe 57 or 60 will be good. 57,000 or 60,000 will be good. So that once we've planted 57,000, we'll come and have 55,000 germinating. So from there, we have these selections. So if we plant at 80, we get to 125 lines. We plant at 70, we get to 142 lines. Then we come to spacing. So if we space our crops at 25 centimeters, how many grains are you going to have per meter? It will be 2,500 divided by 25. We get to 4. So 4 per meter. And 1 hectare is 100 meters. So you're going to say 4 times 100. So meaning that one line will plant, one line is going to plant is equal to 400 seeds, one line. So you multiply this by, we start with 80 spacing by 125. Then we try and find what will be the total population. 400 seeds, which is one line, times 125. then we get to 50,000. We get to 50,000, 1, 2, 3, seeds or plants per hectare. Already, our target is 57 or 60 because we want what should germinate should go to 55,000. Meaning that we put this aside. Then we come to 400 by 142. Okay? So we say 400 times 142. We get to 56,800 seeds. This is better. Our target is something slightly more than 55. But now we are getting about 56,800. Meaning that even if you have 1,000 seeds not germinating, you are still within the range of the average rating. Even if it drops further, maybe to 54, that is still okay. So, what are we saying when we have calculated this? We are now concluding to say, it's better we use 25 by 70. Because 70 will give us 142 lines, which we multiply by 4. If we are not happy with this, we can still reduce this to 20 centimeters. So 20 centimeters from one seed to the next, we say 100 divided by 20. We have 5 times 100. We have 500. 500 times 142. It will be too much. Beyond, way beyond the 60 limit. So, therefore, we will now help the client and say, we are going to do from one plant to the next, 25. From one line to the next, we'll do 70. By doing this, we are actually planting 56,800 seeds per hectare, which is within the range for the requirement for, per hectare. Then we have this determined. Mind you, the first one the client told us. Now we have determined 25 and 70. Then we go to the manual again. So from here, we have 25 and 70. Then we have started now, we want to find A, B, and C. So from this calculation, we want to find A, B, and C, D. So here we come again. We have the important information that we have deduced from our calculations. We go to the tables again. So we get to the tables. The first table for maize. Okay. Okay, so our corn table is here. Again, so we want to plant at 25, and 25 into 100 gives us 4 seeds per meter. So our combinations remain the same. Our combination will remain the same. It's going to be 80, 13. So we find 8 here, then 13. But we still need to find C and D. Okay, so we go to the table that has 8, 13, like we did with the first one. So we find 8 and D, A and D, and our table is here. 8, 13. We use the same table because the seed combination is the same. We are still using 25 centimeters. But this time we are using 70, which is 700, instead of 800. The first client told us 800. Now we've deduced and calculated 25 and 70. So our concentration now will be here. Okay? Up to there. This is going to be our concentration. So now we need to look for 200 again from here. We go and then we have 202. Then we check again. We have 227. So the closest is 202. So now we check what combination will give us 202. We have to go and find the 8, 8. So now for this client, it's going to be 8/8. Everything is almost the same except for this. Why? Because it's reduced to 70 instead of 80. So this now becomes the correct formula. This we go ahead and start changing the sprocket A, B, C, D. Once we have done that, our fertilizer will be applied 200 kgs per hectare, and then we'll be dropping our seeds at 25 centimeters, then 200 kgs per hectare. Then we have calibrated. This is the calibration that you're supposed to do. Okay, so I just want to mention something on the tables. We need to be sure what table we are using. In this case, the one for corn is just one, so we don't have problems. But you find in some cases the tables are more than one. I'll give you an example of soybeans. Okay, so soybeans table is here. Soybeans table is here. So you have soybeans distribution table, but you have got this table, there's this table, and also this table and this one. The question is, how do you know which table to use? So let's pay attention. We need to understand our product. So this planter comes with the seed plates that are of different sizes here and there. But we need to know that it comes, for soybeans, it has 90 holes, 45 inside and 45 outside. So now look at this table here. This has 38 holes. So if we end up just jumping onto any table and use it, we're going to get it wrong. So we need to ensure that we know, we check first 35 holes, 38 holes, 38. This is not our table. There is no seed plates with this number of holes, 62 holes, but our holes are 90. So with this planter, the table you can use only is this one for soybeans. I find a lot of people making mistakes using just any other table. The question is, how do you choose this table over this one? What criteria do you use? So this is very important. You need to look at this number of holes. Though there's an error here, forget about this 8, it's supposed to be 4.5 millimeters. Yeah, I understand how this came about. So please use this table for soybeans. For maize also, you need to know that our seed plates are supposed to have 26 holes, and if you count them, that's what is there. So even when you are trying to perforate your own holes to accommodate certain grain, let's say for maize, it's too big to be used by whatever we supply, you want to perforate your own holes, ensure that the number of holes on the seed plates are 26. Don't just make holes and maybe they are more than that. If they are more than 26, this won't apply. The table applies for seed plates that have 26 holes and fitted with the knocker for maize. That is very important. So soybeans also, if you are going to make holes for beans, this is beans, you need to have 20 holes. If it is going to be sorghum, you need to have, so for sorghum also, the one that we have, we use 90 holes. The one that is coming with a planter, it's about 90 holes. Don't use any table like that. So this is the part that is very important. If you want to plant your sunflower, you can use this 20 holes, but then we do not have seed plates that are 20 holes. Sometimes just use your mathematics. Okay, what do I need to achieve? About 3 seeds per meter. So you can still use a seed plate for maize, which can give you 3, maybe even 5, but use that same combination. What is important is the seedlet. So you can work around that, and you get to use the planter, the manual nicely, and you get your calibration proper. Thank you. So there's this this rod. This is the one that holds the quarter disc for fertilizer. There's actually a tube that comes from this going down into the quarter disc. Then there's also another tube that takes fertilizer down. But what I want to talk about is in case it's fitted on these 3 holes. Right now it's on the center, but there are times when you want to apply fertilizer that is not supposed to mix with the grains. Shouldn't be in contact with the seed that you are planting. This is where you have this hole. So you remove it from here, you put this pin and then push it on the side. But it can't go if you do not undo this part here. There's a part down here which you need to loosen and then you put it on the side, so that when you are planting, your seeds are planting, your planter is planting the seeds away from the fertilizer, for fear that your seeds will be damaged by the fertilizer. So if you have no problem, you can mix them, leave it on the center. This same one again can actually control your depth of application. If you want to take it deeper, there's a pin that will drop and push up and all that. So I wanted to also talk about this, because people ask what is this for, but that is the function of this. Put it on the side, then you are able to put the fertilizer on the side instead of on the same line with the seeds. A number of farmers, when they get the PLB planter, they actually close up this hole. If you check, this hole is on both sides, the other side and here. The purpose of this hole is to work as an inspection port, or something that will tell you that something is wrong inside. So if you are planting nicely, properly, without problems, nothing will come out. But in an instance that fertilizer get clogged up, maybe there's a lamp that has closed the hole, so fertilizer will start coming out. So this is an indicator to say something is wrong within the system. So you leave it open, and when it starts oozing out, that's when you stop and then start cleaning up. So it works as an inspection port, or something that helps you tell you to say the planter is not planting properly, or it's not delivering the fertilizer nicely. So I don't know why people close it, but I've seen quite a number of farmers who do not understand why this hole is there. They end up putting sacks or plastics there, and then they close it up. But then how can you know now that this is it's clogged? If it is stuck, you can't know. Now you keep on going without you knowing, because this does not serve its purpose, because you've closed it. You can't tell. So it's better you leave it open, so that when you see stuff coming out, then it will indicate to you to say there's a lamp here. And we also advise to say, when you're putting your fertilizer, you don't lift the whole sack and push it into the hopper. Check if there are lamps, remove them. There is no sieve there. Bigger planters are fitted with sieves that will ensure that the bigger lamps are actually left on top. But this one, so to avoid such, put it in your bucket or somewhere, then inspect, then that's when you pour it there. You can even use a smaller bucket and start pouring fertilizer in there without problems. But that is to avoid all that.